Okay, so I'm going to be putting in a new tub today, but before I can do that, I have some work to do. I have a new drain kit to put inside. I always like to replace these parts when I can so that I know that everything fits nicely and I have all the parts I need. Also, I have a new shower valve set, so I'll be replacing this valve, I'll be replacing the neck and the head, of course. And so there's going to be some sweat and copper to do today. I've drawn myself a little sketch up here of the dimensions of the tub. I know the center line's at 14 inches. The height of this vent needs to be 15 to the center. The distance from the studs to the rough framing on this wall to the drain is 8 inches. I know the overall width is 32 and the height is 19 and a half. I've made a mark at 19 and a half. That way I know that this filler neck is going to be up above that line. And I like to have my valve at about 32 inches, so I have a mark up here for that. I've also made a mark above for the shower head. Now you can see there was never any block in here to support this. That's another thing we're going to take care of. We've got some pieces of backing to put in, and we're going to be sweating some copper. So before I cut into this copper, I have to shut off the water. And before I do that, I like to fill up 1 cup of water so that I have a drink, and at least 1 5-gallon bucket. And that 5-gallon bucket can be used for a couple things. One's, if I just have some stuff in my hands, I can wash them off. 2, if I need the toilet to flush, I can pour a little bit of it in the bowl. It only takes about 1 gallon to 2 to get a good flush out of a toilet once it's used up. Of course, you have 1 flush on reserve in the tank, provided you don't use it. And it's also good to make sure that you have all of the pieces that you're going to need and do just a layout of the rough assembly before you cut into this, because if you end up having to hunt for parts, you don't want to have the water in the house disconnected at the time. Now if you have more people in the house, you may want more than 1 5-gallon bucket and 1 cup of drinking water. I'm the only one here today, so that should be enough for me. So I have 2 assemblies already put together here. This is my tub drain kit, and I've fit it to the tub off-site so that I know that this is in the correct relationship to this. And while I had that together, I was able to pull some more dimensions and make myself another ugly rough sketch here on the inside of that wall. Now, the other assembly I have is a couple of 45s and another compression fitting. I'll show you why I had that. You'll notice our center line is 14 and a half, but this pipe is sitting at 16 and a half. So I need to move it over 2 inches. Also, one of the other dimensions that I pulled while this unit was on the tub was that the center line of this pipe needs to be 1.5 inches from the framing. And so I'll be able to accomplish both of those things with this offset. Now, the other thing that I know is that the center line of this drain is going to sit at the top of this subflooring. So I can put these 2 together and make my mark down here on this drain pipe. One other thing to notice is that whenever possible, I like to use the kind of funnel technique when it comes to assembling these. I could get one of these that was a female and I could turn some of this stuff around, but I like for this piece to fit inside of this piece, because even if that wasn't glued, the water would tend to want to fall inside of it. And the same thing where this street elbow meets this one, it falls in that way. It's not something you have to do, it's just another one of those steps that is a little bit extra protection. Now obviously I can't do that with the bottom because this has to fit on a piece of pipe. But the more often I can do that, the better I feel about myself, I suppose. Now, I only get 1 shot at this. The PVC cutter usually does a great job, but occasionally it can crush an old pipe. And if it does, I want to know up here rather than down here where the final cut will be made. Nice clean cut. Now I want to dry fit this and make sure that it fits the measurements that I had established. I'm going to mark this with a Sharpie to get my rotation so that I have a good reference. I want to line up those marks. Now I'm just going to glue this in place. They say less is more, but when it comes to glue, if you ask me, more is more. Two reasons why I use a lot of glue. The obvious one being I want to be sure that I have complete coverage. I don't want to get so much glue that it's going to clog up my plumbing, of course, but having a layer of glue in there will lubricate it and give you more working time. You want to hold these together for just a few seconds so that they don't creep. This is flexible, and so 14.5 is right there. When it's vertical, it's right at 14.5. They're gonna wiggle. It's just plastic pipe. Now I'm gonna move on to my pressure side. Okay, so I've shut the water off to the house. I've opened up this, which is a spigot, a hose spigot outside, very close to where we're working here, and that'll let any pressure in this area weep out. I've also dry fit my new valve assembly. Now this product here kind of looks like Shrek's earwax candle. This is just some flux. And just like the PVC glue, I like to use excessive amounts of it. Now since I already have these pieces cut to length, I'm going to want to keep them in order. And so I only take apart a little bit at a time so that I don't get these pieces that are so similar mixed up. This is an inside and outside brush for 1/2 inch and 3/4, which are some very common sized fittings that you're going to have throughout a typical house. Now I've thrown together a really crude fixture here. It's just some scrap lumber that I had in my truck and a couple of screws to hold it together. That's just to give me a working platform. It gets this up off of the concrete, and they're all about the same thickness, so it'll help the thing to sit flat. These 3 pipes right here won't make any difference. They're just going straight into a straight hole. But this is an elbow, a street elbow, and it needs to be straight up and down when it's assembled. So having it rest on this piece of lumber will help to keep that in the right orientation. Now I'm going to hit the fittings. Obviously you can see there's some threads here. You could thread them. To me, that's just another place where you could have a leak. Like I mentioned before, I really like to use flux in excess. Now this cast piece of bronze or brass here is going to take a lot more heat than your other fittings, which is one of the reasons why I like to heat it up first. Because in theory, you could get things so hot by heating up that valve that you actually compromise your other fittings. That's why I want to do that one first. I'm going to do these 3 before I do this 4th one, because as soon as I get that one done, I'm also going to have to do this one. Now that whole valve is pretty hot now. It's not going to take a whole lot more heat to get a good joint going on here. And it's hot enough, I'm not going to need a whole lot of heat to get this elbow sweated either. Okay. Now the guys that do this every day, like I said, they're a lot better and a lot faster at it, and they waste a lot less solder than I do. But I would rather waste a little solder than have to come back and try to fix a joint because I didn't get enough in it the first time around. Now that is so hot that I'm actually going to let it sit and cool before I do the other fittings. The other fittings I have are just these 2 elbows. You'll notice I'm using MAP gas. You can use, the blue bottle, propane, and there's nothing wrong with that. It works fine. It is a little bit slower, but it might be a good choice if you haven't sweated copper before, because it is possible to overheat your copper. This last piece, I just kind of eyeball it. If I have to fix it later, I can, but this should be plenty good enough. The rest of this is sitting flat, and this piece is perfectly vertical. Okay, now it's about time to cut this copper, but first I've opened up the valve by the toilet. That is the lowest opening that I have in this area. And I'm also going to open this valve. And when I do that, even a little bit more water falls out of that toilet valve. We want as much water out of this pipe as we can before we cut it up, because we don't want to take a bath here. Mark the pipe where I want to cut it based off of this assembly and these marks that I've established on the wall where I want everything to be. So 14.5. I'm about an inch to the right, so I'll have to make some kind of an adjustment. Alright, so I have a new assembly here. I didn't bother sweating this out on the ground. These will all sweat just fine where they sit. You can see I have a very specific tool to help align this valve in place, and it's going to sit right there at 14.5 inches exactly. I prefer to orient the flame in a way that it's not going to burn anything unnecessarily. Now before I turn the water back on, I'm going to go ahead and replace the rest of the valves in the room because they all leak, and that's typical. I will have to reassemble this. There's a unit that fits inside of here that acts as the valve. I want to double check my depth front to rear, and I'm going to put a block inside of here, and I'm going to attach this the way it's supposed to be, and I'll do something similar up above. You may wonder why I didn't just reuse this assembly here, and that's a good question. But you see this part right in here that's been smashed? I don't like that. The reason it's there is that whoever put this in put this board flush with the face of these studs. The problem with that is this occupies some space, so this needs to be pushed back at least 3/4 of an inch and leave a reveal on either side. I don't want to reuse this recurrent piece. My new alignment is going to be a couple inches this way anyway, so I'm going to take this off, I'm going to cut the nails out of here and move that back where it belongs. If you're very observant, you might have already noticed that that is a grade 8 bolt welded into a piece of galvanized pipe. Now I want this plastic piece to sit at about 5/8 to 3/4 of an inch from the face of this stud. Now I've seen a lot of these valves that don't have a block back here to hold them still, and that works fine for a little while, but eventually you're going to have some looseness, you're going to have possibly some water damage from this moving around and the water leaking back behind it and getting inside your wall. You don't want that. Take the time to put yourself a little block in, Now I also need to put this valve unit inside this housing. There is a correct way to do it. If you look closely, there's an H on the side of this valve body. Hot water, obviously, it comes in on the left. It's good to lubricate those O-rings just a little bit before they go in as well. Make sure the make sure the H is on the correct side, which in this case is the left. Give that a good hand tighten, and that should be good to go. Even though I've had the water turned off to the house, this valve is still full of water. And see, if I splash the water out of it, it will fill itself back up. That tells me that if I break into this line, I'm going to have a very tough time getting it soldered. So unless I'm willing to use shark bite type fitting or apex type fitting, I'm going to have just a nightmare getting that sweated back together. Now I was going to replace this with a new stub out, because that makes the new construction process go easier. It's easier to put your drywall on, it's easier to tile behind, but I don't want to deal with that. So I'm just going to cut this escutcheon off, and I have a split ring style escutcheon to put back on it, and I'm going to go ahead and replace this valve. You'll want that guy pretty tight so that you know that it's not going to leak. And make sure you shut the valve, otherwise it's a fountain. So this is an example of a pipe that sticks out too far past the ferrule. So what happens when I go to put the valve on there, the pipe bottoms out inside of this valve before the taper on the end of the valve can seat against that ferrule. You see the gap right there? So what I'm going to have to do is take a tubing cutter and cut that guy off. Now she can get all the way against the ferrule where she belongs. If there is a leak, it's usually because there's a joint that I just plain forgot. And since I'll have the water running here, there won't be as much pressure, and I won't soak the room down as bad. But here I go. I'm going to turn on the water. There we have it. Not one leak anywhere. Now I'm going to leave this open for more than a day, and the room will be able to get completely dry, and I'll be able to find any leaks. Now I just need to clean up, and I can put that tub in. This black rubber gasket has to go in between the bottom of this tub and that fitting, and it can be a little tricky to get in there. Next, I'm going to take a gob of this plumber's putty, and I'm going to roll it up like a snake, and then I'm going to smush it around the bottom of this flange here. And that's going to do a couple things. One, it's going to help seal the drain to the bathtub. It's also going to keep this thing from backing out. It'll keep it from coming loose and causing a leak that way. Then I'm going to take my special tool again and tighten this frame up. And if I do everything right, then I'll have a whole bunch of that plumber's putty squish out between the flange of this drain and the edge of the tub. And I'll clean that stuff off, and I will have a nice seal, and it's not going to back up. I also like to have the little cross inside nice and straight, so I'll keep playing with it until I get it just the way I like it. Now the trim on this vent comes with another flat black washer, but this one has a taper to it, so there's a skinny end and a fat end. And so when I did my kind of pre-assembly in the other room, I figured out which side I wanted to go up. In this case, the thick side's going to go up. It is possible that yours may need to have the fat side on the bottom, but that's the way this one goes. There's some clips that come with this, but they're not really necessary. These two screws are what really hold things together, and you need to put a decent amount of tension on them. You don't have to kill them, but there is a seal here, and we don't want water to leak down behind there, so we want it tight enough to seal, but not crazy. So a couple things about setting a tub. If your subfloor is not good and level, like this one is, you may have to do some work underneath. The tub needs to be fully supported. It's got to support, you know, several gallons of water, which is a lot of weight. And if it's not supported properly, it can crack. You want these gaps to be as tight as possible. This one's a little too big. I'm going to have to hit the table saw and get some furring strips and flush that out. Now also, I've got about 3/16 of a flange here that if I just run my material over top of it, it's going to be kicked out. So I'm going to, in addition to fill in these gaps, I'm also going to fur these out so that they're flush and tapered part way up the wall. The back wall, I will fur out all of the studs all the way up so that it's all flush with the inside edge of this flange. In addition to that, I need more backing in this area. So I'm going to be cutting some blocks to put along here. My concrete board is going to be here, my drywall's here, and I want a good intersection between the two. I don't want anything moving and causing cracks. So I'll want more backing all the way up both sides of this, and that'll also give me another attachment point here. The tub is going to need to be level. It's going to be level across here, and it's good. Level across here. Very good. Back here. As well as back here. Now this one is spot on. I lucked out. That's not to be expected. We're also going to run a level up and down these front edges of this skirt to make sure that they're plumb. Now when I shim this spot here, I could put the shim in that way, but that gives me the taper in the wrong direction. So I want to reach down from underneath and slide my shim up this way just until it takes up the slack. We don't want to drive it in like a wedge this time. Now, since this gap is so much bigger, I can put two shims together, but I still want it to taper on the way up. So I'm going to put the fat end of the shim towards the outside, and once I get the corner of this tub screwed in place, I'm going to trim that off. That way when I go to put my furring strips on, there's not going to be a big step. Now this skirt is wanting to roll in on me, and so I want to level it, but I don't want to level it off of the flange. I want to level it from back here. That's where the material will actually go. So here's the last thing I have to address before I can say that this tub is done, and that's this wavy front skirt here. You can see that it's bellied in a little bit when I put my straight edge on it. So my remedy for that I came up with is to take some shims like this. I know shims seem like they might be the answer to everything. And then if I wiggle the bottom one and pull on the top one, I can usually get it drawn back. I don't want to put so much shim in there that it lifts up the edge somehow, but enough to keep tension on it so that it comes out. I'm going to do that in 3 places because this stuff is really just floppy and wavy. I want to pull it all out too far back so that I can take my straight edge and push them all back in evenly. I can slowly push this in until it's nice and straight. Now that I've got that where it belongs, I'm going to take some construction adhesive and glue it in place. Now that the tub is in place, I can more accurately tell where I want this fitting. Now I've already ran this down inside to see just how much effective range I have, and it was about 1.25 inches. So what I want to do is set this 5/8 inside. I'm going to find this, which is going to be the inside edge of that concrete board, and I'm going to add, that's a 1/2 inch thick. I'm going to add another 1/4 inch, so 3/4 of an inch. I'm going to add another 5/8 of an inch to that. And that's where I want the back side of this fitting to sit. And before I sweat that on, I need to pull that O-ring off. Now I do have one more thing to look into before I'm ready to work on these walls, and that's to rough in my electrical. And in this case, that just means running a wire from this lighting sconce to the ceiling for that can light that'll go above the shower. I'm not going to be adding an extra switch in this case. I'm going to have them on the same circuit, so it's just a matter of daisy chaining off of this light and running it over to here. Now this can light that I have is made to go in retrofit, so I'm not going to cut a hole for it until after the ceiling is finished and textured and painted. I will be putting a box in over here on this wall, but I'm going to use an old work style box there as well, and so the wire can be stored inside of the wall until I know exactly where I want that box. I'm just kind of measuring it, eyeballing it. I want to make sure it's plenty long enough, not just to reach the distance, but to also come down into the wall and into the ceiling so that I can tie it together and then push that back up in the attic. I'm going to push plenty of this up into the attic, and then I'm going to leave the rest of it just loose inside of this wall, so it'll be easy to find. And then when I cut the hole in the wall, I'll just be able to reach in and pull the wires out. And just like that, we're all roughed in. See you in the next video. Thanks for watching.